1967. Soviet engineers looked at the new American tractor and laughed. They called it a fuel leak on wheels. They mocked its thirst. They mocked its heat. They didn't realize they were staring at the machine that would harvest circles around their empire. But the International Harvester, 1066 Hydro, didn't win the Cold War with horsepower. It won with fluid dynamics. It used a radical, misunderstood system called hydrostatic drive that traded fuel for something the Soviets couldn't understand: time. The heart of that system was a component you could hold in your hand, a bronze slipper, small, dense, gleaming gold in the fluorescent light of a tractor shop, roughly 2 inches in diameter, surprisingly heavy for its size. The bottom surface was lapped to within 2 light bands of flatness. That means it was smoother than a mirror. It looked like liquid gold solidified. Optical flatness. The kind of precision you'd find in a telescope lens, not in a machine designed to drag a plow through a swamp. This was a piston shoe from the Sunstrand Series 20 to 23 heavy-duty axial piston pump, high-grade bronze alloy. The material choice was deliberate. Bronze is soft enough to conform under pressure, but hard enough to survive 5,000 pounds per square inch of hydraulic force. It sits at the end of 9 pistons, spinning at 2,400 revolutions per minute. Its only job is to press against a hardened steel swash plate without ever touching it. You remember the sound. If you grew up on a farm in the 70s, you remember the sound. It wasn't the low chug of a diesel. It was a high-pitched scream, a piercing, rising whine when the lever was pushed forward. It sounded like a jet engine taxiing. Not a grind, but a pressure sound. That sound triggered a response in every dog within a mile. It was a 1,200 hertz whine that operators learned to diagnose by pitch alone. You aren't imagining it. That wasn't the engine. That was the sound of fluid shear. It was the sound of oil being forced through a brass shoe at 5,000 pounds per square inch. You were listening to the sound of liquid doing the work of solid steel. The bronze slipper was just the interface. The genius was the invisible system that made it work. The system was called hydrostatic drive, and it was a thermodynamic monster disguised as a tractor transmission. To understand why it won, you have to look inside the oil. The conventional tractor used gears, metal teeth meshing together, 96 to 98% efficient at transferring power from engine to wheels. The International Harvester Hydro used pressurized fluid instead, 82 to 85% efficient. 15% of the engine's power was converted directly into heat. The Soviets saw those numbers and declared victory. They presented the efficiency charts in Moscow like indictments. They mocked the heat exchangers on the American tractors as monuments to waste. To a Soviet engineer, the American farmer was burning diesel to heat the atmosphere, while the Soviet gear drive turned every drop of fuel into forward motion. They didn't see a tool. They saw a crime against physics. But the 15% loss wasn't an error. It was a purchase. The engine was an International Harvester DT414, diesel, turbocharged, 414 cubic inches, 6.8 liters, inline 6-cylinder with wet sleeve design, 125 horsepower at the power takeoff on the 1066 model, often dyno tested at 140 horsepower in field conditions. Compression ratio of 16 to 1, rated at 2,400 to 2,600 revolutions per minute. Torque output was approximately 350 to 400 pound-feet at 1,600 revolutions per minute. Direct injection with a rotary distributor pump, either Rusamaster or Ambac design. Fuel consumption was 7 to 9 gallons per hour under full load, high compared to gear drive. Thermal efficiency of the engine alone was 32 to 35%. The cooling system was engineered for punishment. High-capacity radiator with transmission oil cooler integration, dual-circuit design. The hydrodrive dumped massive heat into the oil, requiring heat rejection capability 30% higher than gear tractors. Oil capacity was 18 quarts for the engine, but the transmission reservoir held a staggering 20-plus gallons of high-tran fluid to act as a heat sink. Starting system was 12-volt electrical with dual heavy-duty batteries rated at 900-plus cold cranking amps. Ether injection assist for cold weather starts. This wasn't just an engine, it was a mobile power plant designed to run at maximum output for 16 hours straight. The critical difference was where that power went. In a gear tractor, the engine speed determined both ground speed and power takeoff speed. If you slowed down to navigate heavy crop, you lugged the engine down. The power takeoff slowed, the thresher slowed, the combine clogged, you stopped, you backed up, you cleared the slug, you lost time, you lost grain on the ground. Every clog cost you 30 seconds. 30 seconds multiplied by 50 clogs per day meant 25 minutes of dead time. 25 minutes when the thresher sat idle while the sun moved and the weather threatened. The hydro decoupled those variables. The engine ran at a constant 2,400 revolutions per minute. Always. The power takeoff ran at full speed. Always. The thresher ran at optimal speed. Always. Ground speed was adjusted independently by tilting a plate. This was a constant speed drive system. The same principle that kept alternators spinning at precise frequency in a B-52 bomber at 40,000 feet was now keeping a thresher drum spinning at optimal speed, regardless of how fast the tractor moved through wheat. The swash plate, zero tilt, meant the pistons didn't move in or out. No fluid moved. The tractor was stopped even if the engine was screaming at 2,400 revolutions per minute. Forward tilt meant the pistons stroked out, pushing fluid to the motor. The tractor moved forward. Reverse tilt meant the pistons pushed fluid the other way. The tractor moved backward. The magic was infinite speed ratios, 0.1 miles per hour to 20 miles per hour without touching a clutch or gear stick. Infinite ratios. That means any speed was possible. There were no fixed gears, no stepped progression. While the Soviets were stuck in Gear 4 or Gear 5, the Hydro operated in the infinite ratios between them. The swash plate was hardened tool steel, heat-treated and precision-ground. The plate didn't spin, it only tilted. That was its entire function. But that tilt was controlled with such precision that a 1 millimeter movement of the control lever translated to a fraction of a degree change in plate angle, which translated to an exact change in ground speed. The engineering tolerance was measured in arc seconds. This level of precision required manufacturing capability the Soviets couldn't replicate at scale. You remember seeing a hydro tractor stop on a hill without the brake lights coming on. It looked like magic. The driver just pulled the lever back, and the 10,000-pound beast froze. This is dynamic braking. The fluid locked the wheels. The engine was holding the tractor, not the brake pads. It was a system where stop wasn't an action. It was a state of hydraulic equilibrium. The pressure in the system created a hydraulic column that was incompressible. Moving the tractor required compressing that column, which required force greater than the engine could provide in neutral position. The result was a parking brake that required no mechanical engagement. The Soviets built their tractors at the Minsk Tractor Works and the Kirovets Design Bureau. The MTZ, Belarus, and Kirovets tractors. They were indestructible, they claimed. Simple, most efficient. They claimed their tractors could be repaired with a hammer in a field in Siberia. The gearboxes were bulletproof, 16 speeds. Some models had even more. Manual clutch. Mechanical efficiency was sacred. The gear teeth were cut from solid steel billets. The housings were cast iron thick enough to stop small arms fire. These were tractors built to survive, not to optimize. But those shift levers required 50 pounds of force. The clutches were stiff, requiring leg strength that excluded smaller operators. The efficiency of the gear drive was lost because the operator was exhausted by noon. The MTZ operator fought the machine for 8 hours and went home depleted. The hydro operator guided the machine for 12 hours and came back the next day. The Soviets optimized the machine. The Americans optimized the man-machine system. Watch the comparison in real operational terms. Loader work, shuttle shifting. The task: load a manure spreader. Dig bucket into pile, reverse, drive forward to spreader, raise bucket, dump, lower bucket, reverse back to pile. Repeat 200 times. The Soviet gear tractor cycle. Stop, clutch in with 50 pounds of leg force, shift to reverse while holding the clutch. Clutch out, move 5 feet, stop, clutch in again, shift to forward, clutch out. Cycle time, 12 seconds. Operator fatigue, extreme after 100 cycles. The American Hydrocycle, move lever back, tractor reverses instantly, move lever forward, tractor advances instantly. Cycle time, 6 seconds. Operator fatigue, minimal. The Hydro did twice the work in loader applications. The fuel efficiency argument evaporated in the face of time efficiency. Harvesting wheat, heavy crop patch encountered. Crop density varies across the field. In some areas, the wheat is thin. In other areas, it's so thick the thresher struggles to process the volume. The gear driver had 2 choices: declutch and downshift, stopping the harvester intake completely while the shift happens, or lug the engine down, risking a plug-up that requires a full stop and reverse to clear. Time lost per incident, 30 seconds. Occurrences per day in variable crop, 50. Total lost time, 25 minutes. But that's not counting the clogs that required backing up. Add another 15 minutes for those, 40 minutes of dead time per day. The Hydro driver pulled the lever back slightly. Ground speed dropped 10%. Engine revolutions per minute stayed at maximum. Thresher maintained full drum speed. The slug of heavy crop was processed without hesitation. Pushed lever forward. Ground speed returned to optimal. Time lost, 0. Yield retained, 100%. The tractor adjusted to the crop. The crop didn't dictate to the tractor. The calculation wasn't close. The Hydro harvested 15 to 30% more acres per day, completely negating the fuel efficiency loss. A gear tractor might harvest 80 acres in a day. The Hydro harvested 95. The difference was 95 acres of grain in the bin versus 80 acres. The 15 acres of extra production paid for the extra fuel 3 times over. The Soviets were optimizing for the tank. The Americans were optimizing for the harvest. Soviet doctrine viewed the hydrostatic drive as proof of capitalist decadence. They looked at the automation and saw laziness. To them, a transmission that adjusted itself to the load was an admission that the driver was too weak to dominate the earth. They believed that if the engine bogged down, it wasn't a gearing problem, it was a lack of revolutionary will. They looked at the climate-controlled cab and the Hydro lever and saw a weak operator. Americans looked at the same operator and saw a pilot. The Soviets wanted a heroic worker who struggled. Americans wanted a productive worker who finished. They presented the automation as moral failure. The reality was aerospace precision applied to agriculture. That bronze slipper you could hold in your hand was being pressed against the steel swash plate with 5,000 pounds per square inch of force while spinning at 2,400 revolutions per minute. It never touched the plate. It rode on a microscopic film of high-tran fluid, approximately 3 to 5 microns thick. Thinner than a human hair. The fluid film was maintained by tolerances measured in light bands, surface flatness measured in wavelengths of light. If the bronze slipper scratched the steel plate due to dirt in the oil, the high-pressure seal was broken. The tractor would lose all torque instantly. This required discipline the Soviets mistook for fragility. The transmission held 20 gallons of fluid, not for lubrication alone, as a thermal sink. The heat generated by pressurizing oil to 5,000 pounds per square inch had to go somewhere. The external oil coolers were 30% larger than necessary for a normal engine, massive finned radiators mounted in front of the main engine radiator. The entire chassis was a heat exchanger. The transmission case was grade 30 to 40 gray cast iron, acting as a massive structural chassis member and radiator simultaneously. The case itself weighed more than a modern compact car, over 800 pounds of solid iron. The hydraulic lines were seamless, cold-drawn steel tubing and multi-wire braided rubber hoses rated for 5,000 pounds per square inch burst pressure. The seals were nitrile for standard temperature zones and Viton fluoroelastomer for high temperature zones near the pump. Every connection point was a potential failure point, which meant every connection had to be engineered for perfection. The system had over 60 high-pressure connection points, 60 opportunities for failure, 60 reasons why sloppy maintenance killed the machine. Walk into an old International Harvester dealership shed today. You can still smell it, sweet, burnt, syrupy. That is the smell of high-tran fluid. It's a non-Newtonian fluid designed to hold viscosity under high shear and encapsulate water to prevent rust. That smell is the specific chemical additive package breaking down under extreme thermal stress. It smells like burnt sugar, but to a 1970s farmer, it smelled like speed. It smelled like the ability to keep moving when everyone else had to stop. The system dumped massive heat into the oil, requiring heat rejection capability 30% higher than gear tractors. The cooler fins had to be blown out with compressed air daily during harvest. Chaff buildup meant overheating, meant death. Thermal breakdown of the fluid. If the cooler clogged or the operator overloaded the system for too long without airflow, the fluid temperature would spike past 220 degrees Fahrenheit. Hot fluid becomes thin. The pistons in the pump bypass fluid. The tractor slows down despite the engine screaming. Seal failure follows. Hardening of O-rings and gaskets, leading to catastrophic leaks. In winter, hydro operators were the warmest. The cab was always warm. You remember the floorboards getting hot enough to melt your boots if you weren't careful. That wasn't a heater. That was thermal rejection. The transmission was generating so much heat it turned the cab into a sauna. You were being warmed by the inefficiency that the Soviets mocked. The waste heat was keeping the pilot alive. In January in Iowa, when the temperature outside was 10 below zero, the hydro cab was 70 degrees. The gear tractor driver wore 3 layers and still shivered. The hydro driver wore a T-shirt. The 15% efficiency loss bought human endurance. The invisible component that made the entire system possible was the charge pump, a small, unseen pump inside the transmission that kept the main piston pump fed with oil. It maintained charge pressure in the low-pressure side of the circuit. Without charge pressure, the main pump would cavitate. Cavitation means bubbles forming in the fluid. When those bubbles collapse, they release energy like microscopic grenades. The implosions erode metal. If this $50 charge pump failed, the $3,000 main transmission would starve and implode in seconds. The system had a moral compass. If you treated it with respect, if you bought the good oil and the good filters, it gave you infinite power. If you tried to cheat it with cheap parts, it destroyed itself immediately. It demanded excellence. The filtration was aerospace grade, micron-level fiberglass filters, not paper. Fiberglass media that could trap particles smaller than red blood cells. The bronze slippers required a perfect oil film to survive 5,000 pounds per square inch. Even microscopic dust caused the film to break and the slippers to scratch. Catastrophic failure. Farmers were forced to adopt clean room discipline in muddy barns. The filters had to be changed every 100 to 200 hours in dusty conditions. Using will-fit cheap filters destroyed the tractor immediately. The cheap filters used paper media that would compress under pressure and bypass contaminants directly into the pump. A bifurcation of owners emerged. Those who respected the machine became masters. Those who didn't became amateurs with dead transmissions. The cost of failure was severe. A full hydro transmission rebuild in 1975 cost approximately $3,000. Adjusted for inflation, that's roughly $16,000 today. Compare that to $800 for a clutch replacement in a gear tractor. The hydro punished neglect with financial ruin, but it rewarded care with immortality. The foot-and-inch valve was hidden genius, a hydraulic dump valve connected to the brake pedal. When the operator hit the brakes for a panic stop, this valve dumped drive pressure to tank, disconnecting the engine from the wheels instantly without stalling the engine. You could stop a 14,000-pound machine in emergency conditions without touching a clutch. The deceleration was smooth and controlled. A gear clutch lasted 2,000 cycles before the friction material wore out. A hydrostatic dump valve lasted infinite cycles because nothing touched. No friction material, no wear, just pressure redirection. Soviet clutches required 50 pounds of leg force to disengage. After 8 hours of operation, the operator's left leg was numb. The hydro required the touch of a finger. The control lever operated a servo valve that directed pilot pressure to the main spool. The operator's input was amplified hydraulically. 1 pound of finger force controlled 5,000 pounds of hydraulic force. The Soviets built for durability of the metal. The Americans built for durability of the man. The control lever had hydraulic feedback. You remember having to push it with intention. That resistance was hydraulic feedback. You were physically tilting the swash plate against the pressure of 9 pistons. You were feeling the heartbeat of the transmission in the palm of your hand. The lever didn't flop around. It fought you back. That resistance told you the system was alive. It told you the pump was building pressure. It gave you tactile awareness of system load. Modern drive-by-wire systems have lost this. The operator pushes a button and hopes. The hydro operator felt the machine respond. The capability that made the hydro legendary was the magic creep. Because of the variable displacement swash plate, the tractor could move slower than a clock hand. 0.1 miles per hour, 1 inch at a time to hook up an implement. With a clutch, you risked jumping forward. The binary nature of clutch engagement meant the tractor was either stopped or moving at minimum speed in first gear. With a hydro, you moved with surgical precision. Infinitely variable speed meant you could dial in exactly 0.05 miles per hour and hold it. This was the capability that allowed a single operator to hitch a plow without a helper. Line up, creep backward, stop on a dime, hitch, go. Watch the old footage. When the driver pushed the lever forward, the tractor didn't lurch. It squats. The rear tires dig in, the nose lifts, but there is no clack of the driveline taking up slack. This is the swash plate engaging. There is no air gap in the gears to close. The pressure builds instantly and linearly. The force is transmitted through an incompressible fluid column. It was the only vehicle on Earth that could go from 0 to full power without a single mechanical impact. No shock load, no stress risers, just smooth, progressive force. The scale of deployment was massive. Tens of thousands of Hydro 656, 544, 666, 86, and 1066 models produced between 1967 and 1976. International Harvester held approximately 20 to 25% of the United States tractor market. During this era, with hydro models making up a premium slice. Approximately 15 to 20% of International Harvester sales in compatible horsepower classes. These weren't experimental units. These were production machines sold to working farms. Dominant in the United States Midwest for row crop operations and Great Plains for wheat harvest. Less common in Europe where fuel prices were higher, favoring gears. The price premium was significant. A hydro transmission added approximately $1,000 to $1,500 to the cost of a tractor in 1970, approximately 15% premium over gear drive. That premium bought you a transmission, yes, but it also bought you a complete rethinking of what a tractor could do. Resale value was initially low due to fear of repair costs, but stabilized as the productivity benefits for loader work became legendary. By the mid-70s, used hydros commanded higher prices than equivalent gear models in good condition because operators understood the value. The 656 Hydro was the world's first mass-produced hydrostatic drive agricultural tractor in 1967. First, not experimental, production. Many 1066 Hydros are still running today, 50-plus years later, with 20,000-plus hours, provided the fluid was changed. We are told that high performance means low reliability. The 1066 Hydro laughs at that. There are units running today with 20,000 hours that have never been opened. The fragile fluid drive outlasted the bedrock. Original transmission, original pump, original motor, just fluid changes and filter changes and respect. But it wasn't just operators who had to adapt. The human system required expertise the Soviets couldn't replicate. The workforce structure changed. The hydro operator was often the younger son or the wife of the farmer. The reduced physical strength requirement democratized who could drive the biggest tractor on the farm. No heavy clutching, no wrestling shift levers. A 120-pound woman could operate a 14,000-pound tractor with the same precision as a 200-pound man. This was radical. The gear tractor was a test of physical strength. The hydro was a test of judgment and skill. Dealerships had to send mechanics to hydro school at the factory. International Harvester ran training programs in Illinois. Multi-day courses, hydraulic theory, pressure testing, flow analysis, component identification. A hydro-certified mechanic was the surgeon of the rural county. The certification meant something. It meant you understood pressure drop calculations. It meant you could diagnose a slipping pump versus a weak charge circuit. You couldn't fix a hydro with a wrench and a hammer. You needed pressure gauges rated 0 to 5,000 pounds per square inch and flow meters to diagnose issues. You needed clean workspace and proper fluid handling. The tooling investment alone was $500 in 1975 money. Operators developed a specific auditory tolerance, the hydro whine. 1,200 hertz under load, constant, piercing. It never stopped. Unlike a gear tractor where the engine note rose and fell with shifts, the hydro engine sat at a monotonous roar all day. The ground speed changed. The engine note did not. Operators claimed they could hear the health of the tractor in the pitch. One change in pitch meant a clogged filter starving the pump. One drop in frequency meant cavitation beginning. A rising squeal meant a seal starting to fail. They called the hydro operator lazy because he didn't have to shift, but he had to listen. He was conducting an orchestra of fluid dynamics by ear. One mistake meant $3,000 in repairs. He wasn't a driver, he was a flight engineer. When braking or reversing quickly, the relief valves would chatter or squall like an angry goose. That sound was the safety valves opening to prevent pressure spikes. It was the sound of the system protecting itself. Experienced operators learned to modulate the lever to minimize the squall. Smooth inputs, progressive movements. The machine rewarded finesse. The culture split. Traditionalists sneered. He just sits there and moves a handle. The gearmen called hydro operators soft. They said the hydro was a toy for people who couldn't handle a real tractor. But custom harvesters, operators paid by the acre, loved the hydro. Less fatigue meant longer days, meant more money. A custom harvester could run a hydro for 14 hours straight. A gear tractor operator was spent after 10, 4 extra hours of harvest per day, 4 extra hours when weather permitted. Farm owners were initially skeptical of the fuel cost, but converted when they saw the grain quality. Consistent thresher speed meant less damaged grain, less cracked kernels, higher grade, higher price. The machine paid for itself in yield quality, not just quantity. The safety factor created paranoia. The hydro was safer on hills if the engine ran, but dangerous if it died. The dynamic braking only worked with the engine running. Without the engine turning the charge pump, the hydraulic lock vanished. The tractor became a 7-ton bobsled on a steep grade. This created a culture of paranoia about fuel levels. Never let a hydro run dry on a hill. Operators carried spare fuel cans. They checked levels obsessively. The runaway scenario was rare, but the fear was real. It was the price of admission. The system required total power to provide total control. No power, no control. But there was one memory that made every hydro operator sweat: the hill, the silence. If the engine died on a steep grade, you were in trouble. New operators often burned up the brakes. Why? Because on a hydro, you don't use brakes to stop. You pull the lever to neutral. If you used the foot brakes while the lever was forward, you were fighting the engine with the brakes. The brakes were trying to stop the wheels. The transmission was trying to turn the wheels. The brake fluid boiled. The pads glazed. Brake failure. Old habits died hard and cost thousands. Real operators know why the brake pedals were pristine, because they never touched them except in emergencies. The technology didn't come from farms. It came from declassified aerospace. The heavy-duty axial piston pump technology came from the Boeing B-52 bombers' constant speed drive alternator systems and naval gun turrets. The B-52 needed to keep alternators spinning at exactly 400 Hertz, regardless of engine speed, to power avionics. The solution was a hydromechanical constant speed drive, variable displacement pump, fixed displacement motor, infinite ratio. The same principle that kept radar screens glowing at 40,000 feet was now keeping thresher drums spinning at optimal speed in Kansas wheat fields. The American farmer was driving declassified aerospace tech. The B-52 bomber and the 1066 tractor shared a secret. The swash plate mechanism that allowed the hydro to vary speed infinitely was the same principle that kept alternators spinning at constant frequency regardless of engine speed at altitude. The hydro represented a philosophy. Soviet doctrine demanded that machines be simple enough for conscripts to repair in the field with minimal tools. American doctrine demanded that machines be sophisticated enough to multiply the capability of trained professionals. The Soviets wanted mass production of adequate tools. Americans wanted small batch production of superior systems. They put a component with the tolerance of a telescope lens into a machine designed to drag a plow through a swamp. And it worked, not despite the precision, but because of it. The golden era lasted less than a decade. Then the world changed. 1973, the oil crisis, the Arab oil embargo. Diesel prices didn't just rise, they quadrupled overnight. The math that had been written in favor of the hydro was erased and rewritten. The 15% efficiency penalty of the hydro suddenly became a massive economic liability. The calculation that had favored time efficiency over fuel efficiency flipped. When diesel was 30 cents a gallon, burning an extra gallon per hour to harvest 15% more acres made perfect economic sense. When diesel hit $1.20 per gallon, that math collapsed. Farmers could no longer afford the premium for comfort and productivity when fuel became the dominant operating cost. The productivity gains were real, measurable, documented. But when fuel became the largest line item on the balance sheet, the calculation changed. Sales of hydros plummeted. The 1980s farm crisis finished what the oil embargo started. Farm debt exploded, land values crashed, interest rates hit 20%. Farmers could not afford the premium for operator comfort when they were fighting foreclosure. The banks didn't care about acres per day. They cared about debt service. The market demanded cheaper, simpler transmissions. The hydro was replaced by the power shift transmission. Multi-stage wet clutch packs, planetary gears, good enough shifting without the severe fuel penalty. Not infinite ratios, not the magic creep, but acceptable, adequate, efficient enough. The hydro didn't fail, geopolitics failed. The moment fuel became expensive, the luxury of infinite speed became a crime. The machine that could harvest circles around anything else on Earth was suddenly economically unviable. We traded the best transmission ever made for a few dollars at the pump. The accountants won, the engineers lost, and the fields got slower. Production ceased in 1976 for most models. International Harvester tried to save the concept with improved efficiency, but the damage was done. The market had spoken. Fuel economy trumped productivity. The company shifted resources to power shift development. The pure hydrostatic drive for agricultural tractors was abandoned. The tooling was sold. The engineers moved to other projects. The institutional knowledge dispersed. But good ideas don't die. They just wait. The concept returned in the late 1990s and 2000s as the continuously variable transmission. Modern Fendt and John Deere CVTs use a hydro-mechanical split, part gear, part hydro, planetary gear sets combined with variable displacement pumps, the infinite speed of the hydro with 85 to 90% of the efficiency of pure gears. They added planetary gears to save fuel, but the hydrostatic variator is still the heart of the machine. The pure, massive hydraulic power transfer of the 1066 Hydro is a relic. Modern CVTs are hybrids, compromises, but the principle won. Drive a brand new $500,000 Fendt today. You push the joystick, it just goes. Infinite speed, no shifts, constant engine speed, optimal power takeoff. It feels exactly like the old 1066 because the ghost is still there. The 1066 didn't die. It just got a computer upgrade. The swash plate is still there. The bronze slippers are still there. The high-pressure circuit is still there. They just added epicyclic gears to split the power flow and recover some of the lost efficiency. The global irony is exquisite. In the end, even the Soviets capitulated. When they built their massive harvesters in the late 1980s and 90s, they quietly installed hydrostatic drives. The Don 1500 combine, Soviet-built hydrostatic ground drive. They admitted without saying a word that when the harvest is on the line, you don't use gears, you use fluid. They mocked the inefficiency for decades. They presented papers at agricultural conferences explaining why the Americans were wasting energy. Then they copied it. The technology they ridiculed as decadent became the standard for their most critical agricultural equipment. The gear drive was honest, they said. The hydraulic drive lies. But the harvest doesn't lie. The Don 1500, with its hydrostatic drive, could harvest in variable crop conditions that would have clogged a gear drive machine. Physics won, ideology lost. Every flagship tractor from every nation today uses a CVT, including modern Russian Kirovets models. The mocked technology eventually won, but it had to evolve to save fuel. The Soviets were right about the fuel efficiency. Physics doesn't negotiate. Thermodynamics is Marxist, they said. Energy cannot be wasted. They were correct. The Americans were right about the productivity. Economics doesn't negotiate either. Time is the only resource you can't buy more of. Both truths were valid. Today's answer is a hybrid that respects both. But the pure hydro, the one that traded 15% of its power for infinite control, that machine existed for one glorious moment when we believed precision was worth the cost. Let us count what was traded. The transmission case was a single casting of gray iron, 800 pounds of solid metal. Modern frames are stamped steel or aluminum composites, lighter, cheaper, less durable. Bolt-together assemblies instead of monolithic structures. The lever was connected directly to the valve through mechanical linkage. You felt the pressure. Modern systems are drive-by-wire, electronic sensors, digital interpretation. The operator no longer feels the pressure. The connection between human and machine is severed, mediated by software. The hydro could be rebuilt indefinitely. The Sunstrand pump could be disassembled on a workbench. New slippers installed, new seals, new bearings, reassemble, run for another 10,000 hours. Modern sealed units must be replaced as complete assemblies. No rebuild, no repair. Dispose and replace. The manual recommended changing 20 gallons of fluid annually. Modern transmissions are filled for life, which means filled until failure. The manufacturer determines the lifespan, not the maintenance schedule. The operator had to listen to the pitch of the whine, sensory feedback, auditory diagnosis. Modern soundproofed cabs isolate the operator from the machine. Comfort has a cost. The cost is sensory feedback. The operator sits in silence, unaware of system stress until a warning light appears. The paint contained lead for corrosion resistance. Alkyd enamel. It lasted 40 years. Modern eco-paint peels in 5. Environmental compliance traded durability for reduced toxicity. The cooler fins were steel, thick, solderable, repairable. Modern plastic and crimped aluminum coolers fail faster and cannot be repaired. The mechanic needed to understand physics, pressure, flow, heat, viscosity. Modern technicians plug in a laptop. The computer tells them which module to replace. Diagnosis is binary. Understanding is optional. The hydro ran hot enough to heat the cab. Waste heat was captured and used. Modern efficiency focus minimizes waste heat, but maximizes complexity. More components, more failure points. It was built to run for 30 years. Design life was measured in decades. Modern machines are designed for 5-year lease cycles. Planned obsolescence, economic efficiency over engineering permanence. We did not lose the technology. We lost the will to pay for it. The capability still exists. The knowledge still exists. What disappeared was the market willingness to accept the trade-off. Fuel efficiency became the dominant variable. Everything else became secondary. Productivity, durability, repairability, all sacrificed on the altar of miles per gallon. The hydro demanded that you value time over fuel. The market decided fuel was more valuable. But somewhere, the evidence remains. In a tractor graveyard in Nebraska, in a salvage yard where the red paint has faded to rust, rows of dead 1066s, hoods missing, tires flat, but the transmissions are still there. Massive iron cases slowly returning to oxide. There is a bucket of bolts, parts scavenged from a disassembly. Inside that bucket is a bronze slipper, small, dense, scarred. The bronze is scored and blue-black from heat, discolored from thermal stress. This slipper died because the oil cooler clogged in 1978. The operator didn't clean the fins. The fluid temperature spiked. The heat of the inefficient system fused the bronze to the steel plate. The tractor stopped moving. The transmission was removed, disassembled. This slipper was discarded. It lies in a bucket of rusty bolts, forgotten. It represents a time when we built mechanisms so precise they required clean rooms, then threw them into the mud. It is a piece of aerospace technology left to rot in a cornfield. The tolerance that made it work was the tolerance that made it vulnerable. The precision that gave it capability was the precision that demanded discipline. We built it anyway. For a brief window, we believed that excellence was worth the cost of maintaining it. Look closely at that brass slipper. It is scarred, it is burnt, it is obsolete. But for one glorious decade, it was the only thing on earth that allowed a man to move a mountain with the tip of his finger. It floated on a film of oil thinner than a human hair, transferring 5,000 pounds per square inch of pressure without ever touching the surface it pressed against. It was a miracle of materials, science, and fluid dynamics, spinning at 2,400 revolutions per minute in a cast-iron housing bolted to a frame that weighed 7 tons. The surface that looks damaged was once polished to within 2 light bands of flatness. That means when they tested it at the factory, they placed an optical flat against it and counted the interference fringes. 2 bands, 2 wavelengths of light. That's flatness, measured in nanometers. They achieved that tolerance in a component destined for mud and manure and dust. They achieved it because anything less meant failure. The film of oil that separated bronze from steel was only stable if both surfaces were perfect. Any deviation, any scratch, any pit, and the film collapsed. Metal touched metal. Friction generated heat. Heat broke down the oil. The system failed catastrophically. This component represented a philosophy. We can build things to impossible standards and make them work in impossible conditions. We can take aerospace precision and agricultural brutality and force them to coexist. We can demand that farmers maintain their equipment to laboratory standards, and for a decade it worked. The farmers who understood maintained their hydros religiously. 20-gallon fluid changes, filter changes every 100 hours, daily cooler inspections, and their tractors ran forever. The farmers who didn't understand bought cheap filters and neglected maintenance. Their tractors died. The machine was the accountability system. It rewarded excellence and punished mediocrity with ruthless efficiency. The Soviets looked at this and saw decadence. They saw a system that required too much care, too much precision, too much discipline. They were wrong. They saw fragility. It was actually intolerance. Intolerance for compromise. Intolerance for inadequacy. The system didn't fail. Operators failed the system, and the system punished them for it. That's not fragility. That's consequence proximity, immediate feedback. You knew within hours if you'd made a mistake. The transmission told you. With heat, with noise, with loss of power. You learned or you paid. The Soviets saved the fuel. The Americans saved the farmer. And in the end, you can drill for more oil, but you can never drill for more time. The harvest window doesn't negotiate. The weather doesn't wait for you to shift gears. The crop doesn't care about your fuel efficiency. It cares about being harvested before the rain comes. The hydro understood that. The 15% it burned in heat bought the 30% it gained in speed. That wasn't waste. That was investment. An investment in time. The most valuable commodity in agriculture.